Okay. Okay. Good evening, everyone. My name is Chandan Kumar Gupta. I am a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I am your PMRF NPTEL TA for the course Probability and Statistics. This course is offered by Professor Somesh Kumar. He is a faculty in IIT Kharagpur. Okay. Let me share my screen. Is my screen visible?
Yes, sir, visible.
Okay. Thank you. Okay, then this is the 5th week of a 12-week course. Okay, so in the previous weeks, do you have any question?
No, sir, no.
Okay, then today we will mainly discuss about the normal distribution. Okay, it is one of the most important distribution in continuous random for continuous random variable. Okay, and then a similar type of distribution is log normal distribution. Okay, and we will also solve some questions related to normal and log normal distributions. Okay, so let's have a recap first about the normal and log normal distribution. Okay. Okay, then first of all, like, do you know about the central limit theorem?
No idea, sir.
No idea. Okay. I'm just giving a brief about the central limit theorem. Like, if we have a sequence of independent and identically distributed random variable, suppose like this. If we have a sequence of IID random variable, okay, then the distribution of the sample mean or the sample sum under certain condition follows the normal distribution. Okay. Then the distribution of sample mean, that is x bar, or sample sum, that is summation of xi under certain conditions follow approximately normal distribution. Okay. As like as n tends to infinity, means for n large n. Okay. This is the central limit theorem. Suppose we have a x1 follows some distribution, x2 follows some distribution, x3 follows some distribution. We don't know about the distributions actually. Only we know that x1, x2, and x3, these are random variables and independent. Okay. In that case, like summation xi, it follows a normal, approximately normal distribution. Okay. This is the central limit theorem actually. So here it comes normal distribution. So normal distribution, then first, like suppose a random variable x, suppose a random variable x follows normal distribution, then it can be denoted at like this. Okay, X is a random variable which follow normal distribution with mean mu and variance sigma square. This one is mean, and here we will write variance. Okay, sigma square, not a standard deviation. We will also always write variance. Okay, and one more thing, like these are the parameter also. Okay, here mu is the parameter and sigma is the another parameter. So normal distribution has mainly two parameters. Okay, and constantly, or we will denote like this, the parameter itself, the mean and variance in this case. Okay, like in case of suppose X follows binomial NP. Here parameter is N and P. Okay, but am I audible now?
Yes, sir. Yes, sir.
Yes, sir.
Here, okay, thank you. Here X is also a random variable. Like I think I should write Y. Y is a random variable which follows binomial distribution with parameter N and P. But in this case, mean is not N, it's NP, and variance is NPQ. Okay, but in case of normal distribution, the mean is mu itself, and the variance is sigma square. Okay, so its parameter is mean and variance. Okay, so first let us write the PDF of the distribution. Okay, I'll write on the next page. Okay, so the PDF is one upon sigma root 2 pi e to the power minus 1 by 2 x minus mu upon sigma whole to the power square. Okay. Sorry. So this is the PDF of the normal distribution. Here the domain of x is like minus infinity to infinity. Mu also lie within minus infinity to infinity, and sigma is greater than 0. Sigma is the standard deviation and sigma square is the variance of the distribution. Okay. So this is the PDF of the normal distribution. Also, like now we will talk about the moments. Okay. So one very important property like that, like all odd ordered central moment for normal distribution is 0. Okay, so for all odd order moments, central moments, the all order moments are 0 in case of normal distribution. And for even order, central moment will be written as like this. Suppose we are talking about the even order, so we will write like this, which is equal to expectation of x minus mu power 2m. It can be written as like this, sigma power 2m, it's 2m minus 1, 2m minus 3 up to 5, 3, 1. Okay, so this is the case. So for normal distribution, the mean is like expectation of x is mu1 cap. It's not mu1, it's mean is not the central moment. Okay, mean is the non-central moment, mu1 dash. Okay, this is actually mu, and when we will talk about the variance, which is equal to second second order central moment. Okay. And it is when we put the value of m equal to 2 in this, we will get sigma square. Am I writing correct, or there is something for m equal to 1? Okay, yes, not for m equal to 2. For m equal to 1, it will be like sigma square, which is the variance of the normal distribution. Okay. And again, like for mu3 equal to 0, because it is odd order moment. Mu4 equal to like sigma to the power 4 into 3 into 1, which is equal to 3 sigma to the power 4. Okay, so first order moment, like mean, variance, third order moment, and fourth order moment, central order moment. Okay, so the skewness is mu3 square upon mu2 cube, which is equal to 0. That means it is symmetric distribution. So normal distribution is also known as symmetric distribution. It is also known as Gaussian distribution actually, because Gauss has first used this distribution for error calculation. So that's why it is also known as Gaussian distribution or Gauss distribution. Okay. And for measure of kurtosis, beta 2, which is equal to mu4 upon mu2 square minus 3, which is equal to mu4 is 3 sigma to the power 4 upon sigma square minus 3, which is equal to 0. That is, it is neither leptocotic nor platycotic, that is, it is mesocotic. It is also known as normal curve. Okay, mesocotic is also called normal. Okay, so this is the case. Now, the moment generating function. Okay, so MGF or MXT, it is defined as e to the power expectation of e to the power tx, which is e to the power mu t plus half sigma square t square. This is the MGF for the normal distribution. Okay. Okay. Now there are many properties of normal distribution. Okay, we will discuss some here. Hello.
Yes, sir.
Actually, my network there is some network issue actually here.
Yes, sir. Yeah.
Okay. Now it's audible. Okay, then we will going to discuss some property of the normal distribution or normal random variable. Like suppose first x is a random variable which is normal and it follows with mean mu and variance sigma square. Okay, so in that case, we need to find the distribution of y variable which is related to x as this. Okay, so we may write like this: x follows normal distribution with mean mu and variance sigma square. Then y equals ax plus b. It also follows normal distribution, but with mean. Can anyone tell? Hello.
Yes, sir, audible.
Okay, okay. Can you know how we will write like this? Y equal to, which is equal to ax plus b. It can be written like, it can also be follows normal distribution.
Yes, yes, sir,
Sir,
have
because
discussed.
of linear
Okay. Yes, yes.
linearity property of normal distribution.
Okay. My screen is like in dynamic mode, na? Or my screen is freeze because I'm not able to see my screen actually.
No problem, sir, it is visible.
It is visible. Okay.
Yeah.
Last I've written y follows normal with mean a mu plus b and a square sigma square. Okay. So y, it is a linear property, or linearity property of it is linearity property of normal distribution. Okay. So this is one property. Similarly, like we will standardize the normal variate. Suppose here x follows normal distribution. X follows normal distribution with mean mu and variance sigma square. So we may standardize the variable like this, like this, which is equal to x minus mu upon sigma. It is, it also follows normal distribution with mean 0 and variance 1. This is called standard normal variate. In short, SNV. Okay. So standard normal variate, how can we create? Like suppose x is a random variable which follow normal distribution with mean mu and variance sigma square. Then we will minus or subtract the mean value and divided the value by standard deviation. Then it is standardized. So it is called standard normal variate, which is also normal distribution with mean 0 and variance 1. Okay. Okay. So what is the PDF of Z? Because it is very useful, and in all our question we use the standardized variable actually. Okay. So okay. So it is 1 upon root 2 pi sigma. Sigma equals 1. That's why it eliminated. And then e to the power minus 1 by 2 and z square. And z lie within minus infinity to infinity. Okay. So this distribution is also like denoted as small phi. Okay. It is denoted as small phi z. It is a standard notation for denoting the PDF of standard normal variable. Okay. And the CDF is denoted like as capital phi, which is equal to integral over x small phi. Okay. So this is the case. And there are some more property of normal distribution, like okay, like this phi of z equals phi of z plus phi of minus z equals 1. Okay. Suppose it is a normal curve actually. with this equal to 0. Okay, and let this is the point of z. So phi z is what? It's capital phi z is probability that z is less than or equal to z. This is the definition of CDF, and this is the normal CDF. So we can write like this. Okay, so this we need to uh, calculate like the area under this curve or the probability of this. Okay, so this is this quantity plus and minus z because of the symmetric nature of the normal curve. We may also like this is minus z. Okay, so this area equal to this area. Okay, I think my network is also again fluctuating. I'm not audible, I think. Can anyone confirm whether I am audible or not?
Yes, sir, audible.
Audible. Okay, thank you. Okay, start then. Okay, then this area, this is the probability like what? Like phi of minus z. And from this point up to the left side, it is phi of z. So this property can be like used. Okay. Also, similarly, we may also like, let me draw a curve actually. Suppose it is a normal curve, for example. Okay. And this is mu. And suppose this is mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. Similarly here also, it's minus sigma. Okay, so here like in this interval mu plus sigma to mu minus sigma, in this interval, if a random variable is normally distributed, then around 68.26% of probability lie within mu plus minus sigma limit interval. Okay, so this is the property. Also, then plus minus 2 sigma, it is about to 95.44% of probability lie. And in case of 3 sigma, okay, it is around 99.73% of probability lies. So overall, we can say that like in mu plus minus 3 sigma, 99.73% of probability lie. Okay, so normal distribution is mainly symmetric in nature. Like first, it is actually the property. It is the property of the normal distribution. Okay, and you can also it is symmetrical in nature, so you may also write like this. Okay. Like 34.13% lie within mu minus sigma to mu. Similarly, 34.13% lie within this. Around 13.59% lie within mu plus sigma to mu plus 2 sigma. And it is also the same for mu minus 2 sigma to mu plus sigma. And approximately 2.14% of probability lie within 2 plus 3 sigma limit. And similarly, this. Here, the mean, median, and mode both lie at mu. Mean equal to median equal to mode. Okay. Okay. We have some more thing to discuss. Like approximation, normal approximation to binomial and normal approximation to Poisson. Okay. Suppose, for example, let x follows binomial with parameter n and p. So as n tends to infinity, x minus np, which is the mean of the binomial distribution, and under root of npq. This follows normal distribution with mean 0 and variance 1. That is, suppose x follows binomial, but n is large. In that case, we may approximate this variable as a normal distribution. Okay. Similarly, for Poisson also, like x follows Poisson lambda. Okay. So as lambda is large, again, the variable x minus mean of Poisson distribution is lambda, and variance is also lambda. So under root lambda for standard deviation, it also follows normal distribution with 0 and 1 parameter. Okay. So this is the case. Similarly, okay, I think there is less space, but we will discuss again. Okay. We also have some other distribution like log normal distribution. The definition for log normal distribution is like this. Suppose y, which is equal to log x. Okay. Follows normal distribution with mean mu and variance sigma square. Okay. That is, suppose a random variable y, which is a normally distributed with mean mu and variance sigma square. Then x follows log normal distribution with parameter mu and sigma square. Here it is the parameter, not the mean and variance in case of log normal distribution. Okay. The PDF is like this. 1 upon sigma x root 2 pi e to the power 1 by 2 log x minus mu upon sigma whole square. Here x is greater than 0, sigma is greater than 0, and mu belongs to the real number. Okay. So if x or any random variable x follows log normal distribution, if log of x follows normal distribution. Okay, this is the case for a random variable follow log normal distribution. Okay, okay, I have one more thing to discuss actually. I don't have page here. Okay. Problem. I can tell you like the mean and variance. You may already read somewhere. Okay, there is one more thing like transformation of random variable. Like okay, I think I should write here. Okay, suppose x is a continuous random variable. Continuous random variable. X is a continuous random variable. Then we need to transform or we need to find the PDF of y. X is a random variable like this. Like x is a continuous random variable which follows the distribution fx. Okay, and y equal to like vx is a transformation. Okay, so y is a function of x. We need to find the PDF of y. So in that case, we can calculate the PDF of y like this, which is equal to like f of xy and dx upon dy. If two conditions should be satisfied by y. Okay, what? Like it is first continuously differentiable. Continuously differentiable means like it can be differentiable and the differentiation is continuous. Okay, and the second condition is like this, like it is either non-decreasing or non-increasing. Okay, if these two conditions are satisfied by this transform equation or expression, then we say that we can find the PDF or distribution of y with the help of this formula. Okay, it is one of the formula to calculate the PDF of the transform variable. There are one more formula, more than one, like it is a moment generating method. CDF approach is also there. So we will solve the numericals on both the ideas, the base of both ideas actually. Okay, so okay, then I think we should start solving the numericals from here. If anyone want to ask anything regarding the normal or log normal distribution, he or she may ask. Otherwise, I think we will start from question number 1. Okay. Okay, then, like here, the question 1 is, if the random variable x has the density function 1 by k e to the power minus x square by 4, and x lies within minus infinity to infinity, we need to find the value of k. So one basic approach is like we integrate the given PDF, okay, and equate it to 0 and then find the value of k. Since we are dealing with normal distribution and here it seems like normal, but not exactly. So let's compare the given distribution with the normal distribution. Okay, so like if x follows normal with mean and variance sigma square, in that case, fx should be what? Like 1 upon under root 2 pi sigma e to the power minus 1 by 2 x minus mu upon sigma whole square. Okay. So after comparing these two, we will get some values actually. Okay. So we can write it like gx. So like comparing fx and gx, we get what? Like from here only x square. So that means mu equal to 0. It is clearly visible. Okay, that mu equal to 0. And then like from here on, we can 2 sigma square equals 4. This implies sigma square equal to 2. Okay, because sigma is positive, so we consider the value sigma square equal to 2, and a equal to, it's 1 upon, it's 1 upon k here actually already there. So k equal to like root 2 pi sigma. That means sigma equal to 2. So after solving, we get 4 pi, which is equal to 2 root pi. So k equal to 2 root pi. Okay. So the value of k is 2 root pi for the given PDF to be a density function. Okay. Now question number 2. It is like the mean weight of soldier is 70 kg with standard deviation of 4 kg. Then what is the number of soldiers? We need to calculate the number of soldiers in the regiment of 1000 soldiers weighing more than 74 kg. Okay. So let's just like consider X will be our random variable with defined as like weights of soldiers. Okay, so it is given here X follows normal distribution with mean 70 kg and standard deviation 4, that is 4 square variable. Okay, it is given, and we need to calculate the probability more than 74 kg, that is X is greater than 74 kg. Okay, so we will always use standard normal distribution to calculate this probability, because like suppose if we can write like this, if we can write like this, so this integral is not possible, na? It makes like incomplete gamma integral. So I think we need to use some approximate method or numerical method like Simpson method, trapezoidal rule, something to integrate these type of integration or function. So it is not possible. So we use the normal table to solve this. Okay. So let me erase this. Okay. So we can write like this. We will standardize the random variable as x minus mu upon sigma is greater than 74 minus mu is 70 upon sigma is 4, which can also be written as this is x minus mu upon sigma. It is denoted as z. It is greater than 1. Okay. Okay. Now suppose it is a normal curve. It is z equal to 0. It is z equal to 1. So this quantity is z is greater than or equal to 1. That means we need to calculate the probability of this. Okay. And we know that like it is symmetrical in nature. So probability of z is greater than 0 equal to 1 by 2 is already known. So we may write like this actually. probability that z equal to 0, greater than 0, not equal to, z is greater than 0, then we will minus this area, which is what? Probability that lie between 0 to 1. Okay. So from here, it is 0.5 minus, this can be written as like this, 51 minus 50. 50 is actually 0. So 0.5 minus 51 is capital, actually not small. Okay. So from here, we will check this value from table. Okay. And we will find out the value of this is 0.5 minus the value from this is 3413. So after calculating, we get x is greater than 74 equal to 0.1587. Okay. So this is the probability. Now we have something. Okay. Now we need to calculate the number of soldiers. So the required number of soldiers is,
Excuse me, sir, one doubt.
yes.
How come that probability of z greater than 0 is equal to 1 by 2? Where it is given?
Okay. As we will discuss about the normal distribution, na? So normal distribution has several properties, and one of the property is like it is symmetrical nature. Okay.
Okay.
We will standardize this with the help of this. Okay. So area under this curve is 1. Clear?
Okay.
And it
Okay,
is
sir.
symmetrical about z equal to 0.
Yeah.
So that means greater than z equal to half and less than z equal to half. You can also write like this. Okay.
Okay, sir.
Okay. So we need to now calculate the number of soldiers. Okay. So required number of soldiers is 1000 into probability that x is greater than 74. That means 1000 into 0.1587, which is equal to 158.7, which can be approximated as 159. Okay, so there may be around 159 soldiers, okay, whose weight is more than 74 kg. Okay, we will always use this transformation to solve the normal equation or to solve the probability related to the normal distribution. Okay, because the integration of the normal distribution is not possible. Okay, so we use table. Normal table is already there on internet, on every books of statistics contain normal distribution table. Okay, just try to one thing, always see this graph or this plot when you going to see the table for the normal distribution. Okay. Okay, now next question. Okay, the next question is like the fourth central moment of a normal variate is 768. We need to calculate its standard deviation. Okay, we need to given like what? Fourth central moment, that is mu4 equal to 768 is given. Okay, we need to calculate the standard deviation, which is sigma. Okay, so we know that the central moment The even order central moment can be written like this: sigma to the power 2r, and then it's 2r minus 1, 2r minus 3 up to p1. It is the property we have already discussed in previous slides. Okay, the even order central moment can be written or evaluated with the help of this formula. So, okay, mu4 equal to, that means what? R equal to 2. At R equal to 2, mu4 equal to, sorry, mu4 equal to, it's sigma to the power 4 into 3 to 1, which is equal to 3 sigma power 4. And mu4 is 768. This implies mu4 equal to, sorry, sigma power 4 equal to 768 divided by 3, which is equal to 256. So it is sigma power 4. That means sigma equal to what? We can write 256 power 1 by 4, which is equal to 4 actually, because 256 is the square of 16 and 16 is also square of 4. That means 256 to the power 1 by 4 equal to 4. This is our standard deviation. You may also like solve this with the another method. Can anyone tell me? Since like here we are dealing with normal distribution. So for normal distribution, like it is mesocotic. That means what? Beta 2 equal to 0. That means what? Mu 4 upon mu 2 square minus 3 equal to 0. This implies 768 mu 2 square equal to 3. From here, mu 2 square can be evaluated as 768 by 3. That is mu 2 is again 16. When you will solve, you will find mu 2 equal to 16. So, which is equal to sigma square. So, sigma equal to root of 16, which is equal to 4. So, you may use any property which will strike during the question. Okay, you may use that. Now, the next question is like a sample of 100 items is taken at random from a batch known to contain 40% defectives. Okay. What is the probability that the sample contain at least 44 defectives? Okay. Like it is a very simple question. Okay. First, here we are given any. Okay. Here it is given n equal to 100. We are also given the probability of defective. Let us say small p, which is equal to 40%, which is 0.4. Okay. So, just a second. Yes. Okay. So what? We need to calculate probability that at least 44%, 44 defective. That is x is greater than or equal to 44. So that means we may calculate like this. Because here like x follows binomial distribution, we are given n and p. So n equal to, it's like not n, it's x. 44 to 100. Okay. 100 cx, 0.4 to the power x, and 0.6 to the power 100 minus x. Okay, we need to solve this, evaluate the probability of this question. Okay, of this, like at least 44 defective, which is obviously quite tedious task. So we use the concept of like convergence of binomial to normal distribution, because here n equal to which is large. So we may use the normal approximation here. Okay. So for normal approximation, we need to the value of parameters like mean and variance. So for binomial, expectation of x is what? NP, which is equal to 100 into 0.4, which is equal to 40. So it is the mu. And variance, it's NPQ, it's 100 into 0.4 into 0.6, which is equal to 40 into 0.6 to 24. It is the variance. Okay. So now we approximate this as a normal distribution. Okay. Is it clear now? It is simple, because it is very tedious to solve this question. So we will use the approximation. So now the x follows normal with mean mu equal to 40 and variance 24. And we need to evaluate the probability like x is greater than 44. Which can be know what? One more thing actually. How to solve this now? Is the question. Because we need to use some continuity correction. Sir has already taught, and you may understand like this. Wait. When we are dealing with the binomial distribution, then it is a discrete type of distribution. So at different value x, we have some probability like this. Okay. Okay. So these type of, I think we will get the value of px or probability for the corresponding value of x. But we will, and we approximate it as a continuous distribution. So there will be some continuity correction are made. And this is done with the help of you people already done it. In case we will solving the question related to histogram. Okay, in histogram also we will we have data like the exclusive form of data. Suppose 0 to 9, 10 to 19, 11 to 29. These type of data are given. Then we first convert these data in inclusive form of data or continuous form of data. By what? By subtracting half from the lower limit and adding half in the upper limit. Okay. So it is minus 0.5 to 9.5. It is 9.5 to 19.5 and so on. So now this data, which is called an inclusive form of data. This is the inclusive form of data. It can be converted into exclusive form of data or continuous form of data. So in the same manner, we will also here, we will also done the same thing actually. Okay. So we may write like this. First, x is greater than 0, greater than 44. That means probability that x is greater than 44 and less than 100, because we are having only 100 items. Okay. So now we use continuity correction. So 43.5 x 100.5. Is it clear or not? Because we will transform the discrete random variable into continuous random variable. Okay. So in discrete 1, 2, 3, 4 are there. Na? So we have to convert this data into continuous form. Then we take the difference between these successive terms, which is successive term is 1, then its half is 1 by 2 or 0.5, and 0.5 is subtracted, and we add the in upper limit. Okay, so we calculate this, or we can say that it's continuity criteria to change the discrete random variable into a continuous random variable. Okay. Okay, so we have all what we want. Now it's 43.5. We will standardize 24. Okay. X minus mu upon sigma 100.5 minus 40 upon root 24 because it is there. Okay. So it can be written like what? Root 24 is approximately 4.9, about to 5. Okay. So after solving this, we will get it's around 0.7143. It is Z and it is about to 12.347. Okay. Now again we will draw the curve. Always try to draw curve so you have an understanding of how to calculate this. Okay. Okay. Now it's 0.7143, which is approximately like here. Lies like here. This is 0.7143 point, suppose, and 12 point something, which is something here. Okay, 12.34. So you know that like half of the probability lies here, first thing. Okay, and in half of the probability, we need to calculate only this probability. Okay. So first thing also, like here we have already told you. Let me show you again. Here, in 3 sigma limit, 99.73% of the probability lie within the 3 sigma limit. Okay. So, and we have here like 12 point something. 12 point something. So it is approximately, we can say that it is half. Okay. So we can write like this, na? Probability 12.347. This minus this quantity, which is written like 0 to 0.7143. Is it clear or any doubt? Okay, if there is any confusion, please ask. Okay, so we may write like this as 0.5. Okay, minus, and this can be calculated as what? Again, pi of 0.7143. So when you check, you will get this value from the table is approximately 2624. Okay. So after solving, you will get like 0.2376. the probability that x is greater than 44 is somewhat about 23.76%. Okay. Can you get it or not? Yeah, the question is like we are a sample
Yes,
of 100. Okay, thank you. Like here, sample of 100 items is taken at random from a batch contain 40% defective. So what is the probability that a sample of 100 unit contain at least 44 defective? So the probability that a sample of 100 unit contain at least 44% defective when when the probability of the defective pieces is 40% is 23%, 23.76%. Okay. Always use curve so you have a better understanding to calculate the value of this. Okay. Okay, now question number 5 is if log x base 10, okay, log x follows normal distribution with parameter 7, 3 and log y follows normal distribution again with parameter 3, 1 and these are independent. We need to calculate the value of probability this. Okay. Okay, then first like we are not able to solve this directly like x by y. Okay, we have this type of information, so we consider log. Okay, we will take log of this value. So again, like probability of 1.202 less than x by y. It's not given, it's y given, like x divided by y, x denominator y. It's 831823 zeros are there. Okay. So we will consider or take log. So it comes out to be like log of base 10 is there. So I'm not writing base 10 all the time. Okay. So we will write like this. 1.202 log of x by y log of 8318000 a1 more time 0. Okay, we may write like this. Okay, so 1 point something, so we need to calculate this value and this value first because this follows normal distribution. So okay, now starts log of 1.202 can be written as like log of 1202 divided by 1000 and log of a by b can be written as log of a minus log of b, that is log of 1202 minus log of 1000. Base 10 is there. Okay, so we may calculate this. Okay, with the help of log table, and the value of this is 3.08. You may calculate or you may see the log table. Even you can directly use calculator, scientific calculator are there. Okay, so 3.08 is this and minus 3, which is equal to 0.08. Okay, so log of 1.202 is 0.08. Okay, the first thing is this, and the second thing is like log of 8318000, 4 times 0 is there, which can be written as like 8318 multiplied by 10 to the power 4. So log AB can be written as log A plus log B. So using the same concept, 8318 plus 10 to the power 4. Again, this can be calculated, which is about to 3.92 and 10 to the power 4. It is simple, not 10, it's 4. So this value Here it is plus. It is 7.9. Okay. So now we may formulate this like this. Log of, no need to write log. We may write this as probability that 0.08 less than log x minus log y. Okay, because log of x by y, it can be written as log x plus log y, and then less than 7.92. Okay, now there is one more task is there. If we have something like about some information about this, then we may solve this. If it is normal, then it is clear. So here we see that like log x follows normal, this is given. Log x follows normal 7.3. Log y follows normal 3.1. So anyone can tell me like u equal to log x minus log y follows which distribution? Can anyone tell me with reasons actually? Okay. It is also follow normal distribution because it is a linear combination of normal distribution. The difference of two normal variate is again a normal variate. It is already given at log x and log y are normal distribution, normal variate and are independent. So log x minus log y is also normal variate with mean. You may write like this. X follows normal mu1 sigma 1 square. Y follows normal mu2 sigma 2 square. Then x plus y follows normal mu1 plus mu2 and sigma 1 square plus sigma 2 square. If it is independent, I'm talking about the independence and variable. And x minus y also follows normal distribution with mean mu1 minus mu2 and variance is sigma 1 square plus sigma 2 square. Okay, in both the time it is plus. Okay, variance is plus and the mean value is minus. So with the help of this property of normal variate, we may write like log x minus log y, which is 7 minus 3, which is equal to 4, and 3 plus 1, which is equal to 4. So this quantity follows normal 4, 4. Okay. So the last step is what? Can anyone tell me? What is the last step? Or we may write like this now. Probability that 0.08 minus mean mu, that is 4 upon standard deviation is root 4, that is 2, less than log x u minus 4 upon 2, u is equal to this 7.92 minus 4 upon 2. This is calculated like it is probability. Okay, it is minus 1.96 actually. And it can be written as z because in normal variate, we will subtract mean and then divided by the standard deviation. It is z, which is standard normal variate now. And it is 1.96. Okay, this is the case. Now we need to calculate this. Also, we know that because it is symmetric nature, na? So suppose it is minus 1.96 and it is 1.96. We need to calculate the probability under this curve. Okay. We know that like the probability of this is same as the probability of this because of the symmetricity of the normal variable. Okay. So that means we can write like this also, twice of probability of 0 then 1.96. Is it clear now? We can write like this now. Okay. So this is what 2 into phi of 1.96, which is equal to, if you see this in table, you will find 0.4750. So the probability, you need to calculate the probability of what? It's like this, na? 1.202 x by y. It's 8318444 times 0 equal to 0.95, which is the required answer. Is it clear or not? If you have any doubt,
Yes, sir.
okay, thank you. Any doubt regarding any steps, you may ask. Okay. Okay. Now next question is like x is a random variable with PDF is this. We need to calculate the PDF of x square. Okay, it is a transformation. Okay, it is a kind of transformation question. So okay, we will start like this. We are given the PDF of fx 1 upon pi into 1 upon 1 plus x square. This is a standard Cauchy distribution. It is Cauchy distribution with parameter 1 and 0. Okay. Oh. Okay. Now we need to calculate y equal to x square. Okay, y equal to x square. We need to calculate the PDF of phi, which is equal to x square. Okay. So we will use like CDF approach. Okay. So suppose the CDF of y is capital ZY. And it is defined as the probability that y is less than or y. Simple. We can put the value of y equal to in terms of x, like capital X square less than equal to y. Okay. So it can be written like this. It is simple step actually. Is it clear now? It is simple step. Okay. Now the probability of this, it can be written like this. Okay. We will write like this: integral minus of root y to root y. Okay. And fx dx, which is equal to minus of root y to root y. And it's 1 upon pi 1 upon 1 plus x square dx. Clear up to this point? Okay. Now here it is a function of x. It is x square. No? So here you see that like fx equal to f of minus x. That is what? That is even function. And if it is even function, you may write this like this. Right here. Twice of integral of 0 to root y. 1 upon pi 1 upon 1 plus x square dx. Is it clear? This is a known property. Okay, 1 by pi can be written outside. It's upon 2 upon pi. And integral over 0 to pi 1 upon 1 plus x square. It is nothing but tan inverse x. 0 to root y. Okay. Any confusion up to this point? I don't think. Okay. So we may write like this 2 upon pi tan inverse root y tan inverse 0. Okay. So tan inverse 0 is 0 actually. So you may write it like this 2 upon pi tan inverse root y. Now, what is the range of y? From here, range of x is minus infinity to, okay, this 0 is not there actually. Okay, by mistake it is written here. Okay, it is from minus infinity to infinity. Okay, the range of x is minus infinity to infinity. So y equal to x square. That means the range of y should be 0 to infinity. So this is what? This is the CDF of the y variable, which is y equal to x square. Now we need to calculate the PDF. PDF is defined as what? We will differentiate. Okay. So dy of 2 upon pi tan inverse root y. Okay. So if you solve this, you may find out like this. Y to the power like, sorry, it's around like, okay, it's like 2 by pi is there, tan inverse y. So it is 1 upon 1 plus y square, root y square, that is 1 plus y. And then root y can also be, so y to the power minus 1 by 2 is there. Okay. This quantity is there into 1 by 2. Is it clear up to this point? It is simple differentiation. I think you people may solve. Okay, then it can be like compact form. We can write like this 1 by 2 minus 1. It's pi. It's 1 plus y to the power 1 by 2 plus 1 because it is 1 plus y only in denominator term. And we may write like 1 plus y to the power 1 by 2 plus 1 by 2. I have written this because of, okay, so this is our PDF with the same range. Okay, now it resembles a distribution which is a beta distribution of second kind actually. I can write here like beta distribution of second kind, which is 1 upon beta mn. Okay, x to the power m minus 1 and 1 plus x to the power m plus n. This is the PDF of the beta distribution of second kind. Okay, so from here you may see that after comparing you will find beta second kind, okay, with the parameter value is what? M equal to half, n equal to half. Okay. Any doubt up to this point? Okay, then. Okay, now next question is like if x is a uniform random variable over 0, 1, we need to calculate the distribution of y, which is e to the power x. Okay. Now, okay. The PDF, since x follows uniform like 0, 1, so fx will be 1. 0 otherwise. Okay. And we are given the transformation equation y equal to e to the power x. Okay. So from here, actually when we are saying transformation equation, then we should write it in small letter. Okay. So y equal to e to the power x. This implies x equal to log of y. Okay. Now dx upon dy is what? 1 by y. This is also called Jacobian actually. Okay. And like we may use direct this formula because here y equal to e to the power x is continuously differentiable and non-decreasing function in 0, 1. So we may use direct like dy, which is what? F of xy and dx upon dy. So gy equal to what? 1 into it's 1 by y. So from here, gy can be written as 1 by y. Now it comes to be a range. What should be the range? Okay. So for range, we may write like so x lie within 0 to 1. So x equal to what? Log y lies between 0 to 1. That means e to the power y lies between e to the power 0 to e to the power 1, which is equal to 1 to e. So 1 by y when or 0 otherwise. This is our distribution of the y variable, which is e to the power x. Is it clear? Okay. Now next question. The next question is, if x is a normal random variable with mean 2 and variance 4, then find the mean and variance of y equal to 3x plus 5. Okay. Okay, then since x follows normal mu and sigma square, then and y equal to ax plus b, then it also follows normal with a mu plus b and a square sigma square. We have already discussed this property in previous slide. So we need to calculate the expectation of y. The expectation of x is what? 2. Variance of x is 4. And similarly, expectation of y equal to expectation of 3x plus 5, which is equal to 3 expectation of x plus 5, which is equal to 3 into expectation of x equal to 2 plus 5. It is 6 plus 5, which is equal to 11. And variance of y equal to variance of 3x plus 5, which is equal to 3 square. Variance of x, which is equal to 9 into variance of x is 4, which is equal to 36. So the mean is this and the variance is 36. The simple question actually. Okay. Now question number 9. Okay. Here in a normal distribution, 31% of the item are under 45 and 8% are over 64. We need to calculate the mean and standard deviation of the distribution. We are given this information. Okay. So, okay then. Let's suppose X is random variable which follows like normal distribution with mean, mu, and variance sigma square. Okay. So we have given what? Like probability 31% of the item are under 45. Like 31% are under 45. So X is less than 45. It is given as 31% and 64, 8% are over 64. That is X is greater than 64. It is 8%, 0.08. Okay, these two are given. So we may standardize the variable like this. First, X minus mu by sigma, 45 minus mu by sigma, 0.31, and probability X like mu by sigma greater than 64 minus mu by sigma, it is 0.08. Okay. So from here, we are 45 minus mu upon sigma, and also z is greater than 64 minus mu upon sigma. We have this quantity. Suppose it is equation star. Okay, we have actually a pair of linear equation in two variables. Okay, now the first equation is like this. Okay, now also we have given some condition like this. Okay, here it is 0.31. So since it is written like this, probability like given, we are given like z is 1.4 equal to 0.08. So we can write this like this also. Z is greater than 1.4 because it is a normal distribution and the curve is like symmetrical nature. So we may write this like this, 0.08. Also, the probability is Z is greater than 0.31. Sorry, 0.05 or 31. Equal to 0.31. This implies probability that Z is less than minus of 0. It's 5, not 0.5. Sorry. 0.5 minus 0.5 is 0.31. Okay, and suppose this is equation second star. These two. Okay, now compare this. It is equal to this and it is equal to this with the same equation. Okay, so from comparing these two star and double star equation, we will get what? We will get like this. Probability Z is greater than 1.4. Z is greater than 1.4. Okay, it is equal to this. Okay, so that means probability Z is greater than 64 minus mu upon sigma. And the second one is like probability Z is less than minus 0.5 equal to probability that Z is less than 45 minus mu upon sigma. Okay, so from these two equations, from this equation, we may solve like this, like 64 minus mu upon sigma equal to 1.4. And from here, we will write it like it's 45 minus mu upon sigma equal to minus 0.5. Okay. Now it is a simple task now. Okay. From these two equations, suppose equation A and equation B, you may solve the value of mu and sigma. I will tell you the value. Okay. Like sigma equal to 10 actually. And putting the value of sigma equal to 10, we get mu equal to 50. Okay. You may solve these questions. These are simple actually. We have a lot of question actually. That's why I directly give the answer. Okay. The concept is clear. It is simple like how to proceed. Okay. We have a two pair of linear equations, and by solving those equations, we get the values of the parameter mu and sigma. Okay. So the standard deviation is, our question is, find the mean and standard deviation. So mean is like this 50 and standard deviation is sigma equal to 10. I have repeated. Okay, now next question. Okay, the PDF of a random variable x is given by fx is equal to k e to the power minus x square plus 6x plus 9 divided by 32. Then determine the value of k, also find the mean and variance of x. Again, it is the same kind of question actually. Okay, so like what? We are given like this. Okay, so here minus of x square plus 6x plus 9 can be written as how? It is actually x plus 3 whole square, which is equal to a square plus b square plus 2ab. This can also be written as x minus 3 whole square. Okay. And if there are also 32, it's 32, it can be written as like 2 into 16, which is equal to 4 square. We will actually compare this with normal distribution. That's why we will write like this. Okay. So we can write like this. Okay. So like normal distribution, 1 upon 2 pi sigma e to the power minus 1 by 2 x minus mu by sigma whole square. Okay, this may write like this, x minus of minus 3 upon whole square 1 by 2. So after comparing, we will get what? Mu equal to minus 3 and sigma equal to 4. Okay, and with the help of these two, we will calculate the value of k, which is equal to 1 upon root 2 pi sigma, which is equal to 1 upon root pi into sigma equal to 4, which is equal to 1 upon 4 root 2 pi. We need to calculate the value of k. Now the mean and variance of x. The mean and variance itself, like mean of x, which is equal to mu, which is equal to minus 3. Variance of x, which is equal to sigma square, which is equal to 4 square, which is equal to 16. Is it clear? Now question number 11 is x has MGF of this. Okay, we are given like MGF of random variable x, which is equal to 2t1 plus t. It can also be written like 2t plus 2t square, which is also written. Okay. Now the MGF of normal distribution. MGF for normal distribution is like what? E to the power mu t plus sigma square t square by 2. So like we may write like this, mu t plus it's 2 square. Okay. T square is there. It's 2 square by 2. So comparing these two, see, the MGF has a property like existence and uniqueness property of MGF. Okay, so if a random variable has a some kind of MGF and it is equal to like some distribution, then these two distribution are similar or equal. So this is the existence and uniqueness property. So with after comparing equation 1 and equation 2, we will get what? Mu equal to 2 and sigma square equal to 4 is not 4 square, it's 2 square. No? It is equal to 4. Okay, so that means what? That means x follows normal distribution with mean 2 and variance 4. We will get the PDF of the distribution. Now it is easy task to calculate the probability. So we need to calculate the probability that x is less than or equal to 2, which is equal to what? Again, standardize the same x minus mu upon sigma less than or equal to 2 minus mu is also 2 upon sigma is also 2, which is equal to probability that z less than or equal to 0. And it is well known that it is equal to half. Is it clear now? Anyone have any doubt? Am I audible or not? Hello.
Yes, sir, audible.
Okay, thank you. Okay, now next question is like this. We are given fx is equal to 2x. Okay, for x lies in 0 to 1. We need to calculate the distribution function of y. We need to calculate the PDF of y, which is equal to root x. Again, like we may solve, suppose this is the CDF or distribution of y, gy, which is defined as again like y is less than or equal to small y is a distribution definition of the distribution function, which is what? Y equal to under root x. So we can write under root x less than or equal to y. We can also write like under root x. That means probability that x less than or equal to y square. So it is simple. X is less than or equal to y square means what? It's 0 to y square fx dx. Okay, so we are given like what? 0 to y square and fx is equal to 2x dx, which is equal to 2 x square upon 2, 0 to y square, which is twice and 2. It also that 2, these 2 cancel out, so no need to write this. So it is a. It is y square to the square, that is y to the power 4. And y lies within what? Y lies within 0 to 1 because x lies within 0 to 1. So y also lies in between 0 to 1 and 0 Okay. So this is our CDF. This is our CDF. And this approach is called CDF approach. Okay. We use the formula of CDF and then proceed in a similar manner. We will find the CDF of y, which is equal to root x. Okay. So we have also one, like you may also calculate the PDF. If although it is said the distribution, you may also like which is equal to 4y cube this is the PDF. Okay, we may also use another approach like here we are given the transformation equation like y equal to root x. Okay, so from here on we may write in a small letter x is equal to y square. So this implies dx upon dy, which is equal to 2y. Okay. Also, the range, since x lies within 0 to 1 and x is equal to y square lies within 0 to 1. That means y lies within 0 to 1. Now, here it is a y equal to x square. It is a continuously differentiable function and either non-decreasing or non-decreasing, increasing in nature. That means we may direct use the PDF formula like this, f of dx upon dy, which is equal to what? It's 2x. Okay. So 2x, x is equal to y square into 2 to the 2y Jacobian. So from here it's not 2, it's 4 y cube and the value of y is like this. Is it clear? Now it is simple. Like we use directly this formula and putting the values of dy by dx, sorry, dx by dy and the given CDF function, the given PDF function in terms of y or as a function of y, we will get this. And from both the method, we will find the same PDF 4y cube, 4y cube. Okay. Now, if x is a random variable with probability distribution this for x equal to 1, 2, 3, 4, oh God, then we need to calculate the distribution function of y equal to x square. Okay. So it is like discrete distribution. Okay. It is a discrete distribution. So we need to calculate the range first. Like here x equals 1, 2, 3, 4. So what is the value of y? Since y equal to x square, then the value of y is what? 1, 2 square, 3 square, 4 square, which is like 1, 4, 9, 16, dot dot. So the range of y is like this. Okay. And the next step is what? Since it is a one-to-one function kind of, y equal to x square is a one-to-one function. Okay. So we will directly use like this. Here, like y equal to x square, this implies x equal to root y. So just replace x with root y. Okay. So we can solve this like this. Okay. Okay, yes. We have like this, 3 by 4. It's 1 by 4 to the power x minus 1. This, so replace x with root y. So it's 3 by 4, which is constant. It is 1 by 4. X equal to root y minus 1 and y equal to 1, 4, 9, 16 to sort of. So this is the simple concept. Okay, when we will dealing with like discrete random variable, okay, and it is a one-to-one function between x and y, and in that case, we will directly replace one variable with the other variable with the given relation, not only x is equal to y. Like here, x is equal to y square, sorry, y equal to x square, that means x is equal to root y. So we will replace the value of x with root y. Okay. Okay, now next question is here. Okay, this is the question. Like if x be the number of heads is two tosses of a fair coin, in two tosses of a fair coin, then find the distribution function of y equal to x minus 1 square. Okay, so first we will write the distribution like PMF of x. Okay, so we will write two tosses. So number of head. Okay, so x will be our density like random variable, which is number of heads. So the possible values of x is either 0 or 1 or 2. So like PMF of x is what? X probability that x equal to x. So it's 0. Number of head is 0, it is 1 by 4. Number of head is 1 is 2 by 4. Number of head is 2 is 1 by 4. Okay. So this is the distribution of number of head where we're dealing with two coins. Okay. Now we need to find the distribution of y, which is equal to x minus 1 whole square. Okay, again, for x equals 0, y equals 1, x equals 1, y equals 0, x equals 2, y equals 1 again. So it is not one-to-one function. It is not one-to-one. So simply we will calculate the probability value for the different values of y. Okay. Like okay. So probability that y equal to 0. Y equal to 0 is corresponding to x equal to 1, which is equal to probability that x is equal to 1. So which is equal to 2 by 4. Now probability that y equal to 1, y equal to 1 is corresponding x is equal to 0 and x is equal to 2. That means probability that x is equal to 0 plus probability that x is equal to 2. So probability that x is equal to 0 is 1 by 4 plus probability that x is equal to 2 is 1 by 4. That is probability that y equal to 1 equal to 2 by 4 or 1 by 2 we may write for solving. Okay, so the distribution of y, which is equal to x minus 1 whole square, is when it is 0, it is 1 by 2. When it is 1, it is 1 by 2. This is also the transformation, but in case of discrete random variable. Okay, when we will solving the discrete random variable, then the transformation may be solved either for one function or not one function. In case of one function, we directly put the value of the from the transformation equation. Here it is. Okay, and in here when the transformation equation is not one function, then we will solve by this. Okay. Okay, now like next question is if x follows log normal distribution with parameter and sigma square. It is not mean and variance, it is parameter. Then we need to calculate the PDF of y equal to log x. Okay. So we are given like what? X follows log normal with parameter and sigma square. Okay. And we need to calculate the probability that y equal to log of x. Okay. From here, we will calculate x is equal to e to the power y. So dx, okay, y equal to log x. Log x is differentiable and it is a like non-decreasing or non-increasing. Okay. So both the conditions satisfied. So dx upon dy equal to e to the power y again. Okay. So the PDF of y is like fx of and then dx upon dy. So for log normal distribution, the PDF is like this. I think I should write like this. One upon sigma x root 2 pi e to the power minus 1 by 2 log x minus mu upon sigma whole square. Okay, this is a PDF of log normal distribution. So we will replace this. So it is like 1 upon sigma and x will be replaced by e to the power y. Okay. E to the power y root 2 pi into e to the power like minus 1 by 2 log x. Log x can be written as y minus mu upon sigma whole square into dx upon dy. Jacobian, that is e to the power y. So this e to the power y will be cancel out this. So we will find out like this. 1 upon sigma root 2 pi e to the power minus 1 by 2. It's y minus mu upon sigma whole square. This is nothing but this is what? That is y follows normal distribution with mean, mu and variance sigma square. Simple. So that means what? This is a definition. Like if x follows normal distribution, then y, which is equal to log x, it follows a normal distribution. Okay. So here we have already, like we have proved here. So y follows normal distribution, then log of y, which is equal to log of x, which is equal to y. Okay. That is follows log normal distribution. And here we have proved this. And this is the PDF of log normal distribution. Okay. Now the next question is like, if the amount of time needed to solve a Okay, I think how is it possible? Okay, no problem. If the amount of time needed to solve a problem by a group of students follows a log normal distribution with parameter mu and sigma square, then what is the value of mu so that the probability of solving a problem in 10 minutes or less by any randomly picked student is 95% when sigma square is 4. Okay, so here we need to calculate mu. Here we need to calculate the value of mu when sigma square is equal to 4 is given, and this condition that the problem solving within 10 minutes is 95%. Okay, so let's start. Here it is given already log normal distribution. So that means what? X is the amount of time needed. I have a how I no problem. I think I've written like okay. There is something happening. Sorry for that interruption actually. I don't know how I write here. That's why I'm confused. Okay. Okay, we will solve there. Like we are already given. Okay. Here X is our random variable, which is the amount of time. Which is the amount of time required to solve a question. Okay. So it is given X follows log normal with mean mu and variance. Not mean. It's with mu and variance, and the second is sigma square, which is equal to 4, not variance. Okay. So it is given. Also, it is given that probability that the problem is solved in less than 10 minutes. That is, X is less than or equal to, not equal to, it's only less than, is less than 10 minutes. You may write equal to because it is a continuous distribution, but it's given like this, equal to 0.95. These two are given. Okay. Okay. So that means what? If we consider like taking log, then probability that log of X less than 10 equal to log of, what should I write here, log 0.95. Okay, it is a probability. Na? I'm sorry, there is something misunderstanding. Okay, we have considered log of X is less than log of 10, which is equal to 0.95. Clear? So we know that na, from here also, we know that if y equal to log X, it follows normal distribution if X follows log normal. Similar way, here X follows log normal. So log of X follows normal distribution. That means log of X follows normal. That means probability that log of X minus mu upon sigma equal to 2 is less than log of 10 minus mu upon sigma equal to 2. It is given 0.95. Okay. So from here onward, this. Okay. So probability that Z is less than log 10 minus mu upon 2 equal to 0.95. 0.95. Okay. Okay, now we will use a normal table to check the value of this, for which the probability is 0.95. Okay. And from table, we will find out that probability that Z is less than 1.65 equal to 0.95. That is the value of Z. This quantity is 1.65. So compare these two. That is log of 10 minus mu upon 2 equal to 1.65. And this implies mu equal to like any question? So log 10 here, it is base E. That's why log 10, the value of log 10 is like 2.3025. Okay. Minus it's 3.3 equal to mu. And from here, we will calculate the value of mu equal to like minus of 0.9975. So the value of mu is like this. We need to calculate the value of mu, and the value of mu is 0.9975 negative. Okay. 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 I'm unable to erase this. I don't know. There is some technical glitch or something. I don't understand this. Nothing will work. Okay, no problem. I don't know from where it came. Okay, so leave it. Now the next question is like if x follows log normal 0.4, then what is the probability that x is between 1 and 12.1825? Okay, again it is a yes. I think anyone want to ask anything? Okay. Okay, then like here x follows log normal 0.4. Okay, we need to calculate the probability between this. That is, we need to calculate the probability like 12.1825. Okay, again, similar manner, we will take the log probability that log of 1 less than log of x less than log of 12.1825. Now, since x follows log normal, then log x follows normal. Okay, so that means what? So log of 1 equal to 0 actually. Okay, 0. Suppose it is equal to u and it is equal to log of 12.1825. You may use calculator to find the value. It is means it is equal to like 2.50 actually. Okay. So similarly, the probability that 0. It's mu 0 upon 2. U minus 0 upon 2, 2.5 minus 0 upon 2, which is equal to 0 z, it's 1.25. Clear? Which is equal to phi of 1.25. And again, with the help of normal table, you will find out the value of this is 0.3944, which is a required probability. Okay. Now again, one question, like the time until recharge for a battery in a laptop computer. Actually, these questions are from the previous year assignment, so you have already solution, but let's discuss this one. Okay. So the time until recharge for a battery in a laptop computer under common condition is normally distributed with mean this and standard deviation this. That is x follows normal distribution with mean 260 minutes and standard deviation is 50. That is 50 square is the variance. What is the third quartile? Quartile is actually the positional average. Okay, third quartile, which is denoted as like Q3. So since it is normal, so from there to Q3, fx dx. We need to calculate this. In like, what is the, okay, wait. Yes, this one. And third quartile is what? Suppose it is the whole data. So median divides the whole data into 2 equal parts and the quartile divides the whole data into 4 equal parts. There will be 3 quartiles. This Q1, this Q2, this Q3. Okay. So Q3, that means this has 75% of data and this has 25% of data. So that means it is 0.75. Simple. Now we will solve this. So this can be solved like what? Probability that x is less than or equal to Q3 equal to 0.75. Now again the similar thing, minus mu upon sigma Q3 minus mu. The value of mu is like 260 and the sigma is 50 equal to 0.75. Okay, now the probability that z is less than Q3 minus 260 upon 50 is equal to 0.75. Now again we will see this value from normal table and find out the value of this, and this is approximately Q3 minus 260 upon 50 equal to like 0.68. Okay, so from here like Q3 equal to 0.68 into 50 plus 260, which is equal to 34, not 340, it's 34 plus 260. So the Q3 will be 294. So the third quartile for this is 294. Okay. Okay, then I think we should stop here. If anyone want to ask any question, any doubts, then please ask. Anyone? I am audible, na?
Yes, sir. Yes, sir.
Yes. So if there is no question, then I think we will we may conclude here then. Okay.
Thank you, sir.
Okay, thank you. Stop.